Apprenticeship programs, technical schools, and online programs are all viable routes to further electrical training and career advancement. Firstly, let's consider apprenticeship programs. The International Brotherhood of Electrical Workers, or IBEW, offers a 4-year apprenticeship program combining classroom instruction with on-the-job training. Associated Builders and Contractors, or ABC, provides an apprenticeship program that includes both electrical and construction-related training. The National Electrical Contractors Association, or NECA, offers a 3-year apprenticeship program focused on electrical construction. Secondly, consider technical schools. The Institute of Electrical and Electronics Engineers, or IEEE, offers certificate programs in electrical engineering and related fields. Phoenix College in Arizona provides an electrical technology program leading to an Associate of Applied Science degree. San Jacinto College in Texas offers an electrical technology program with concentrations in electrical maintenance, industrial controls, and residential construction. Thirdly, investigate online programs. edX, in conjunction with the University of Illinois at Urbana-Champaign, offers an online electrical engineering MicroMasters program. Coursera, partnered with the University of California, Irvine, provides a specialization in electrical engineering. Udemy hosts various self-paced online courses on electrical engineering and related topics. Your previous electrical classes and part-time work experience will provide a strong foundation for any apprenticeship or training program. Apprenticeship programs typically require a high school diploma or equivalent, while some technical schools and online programs may have additional prerequisites. Completion of an apprenticeship or training program often requires passing an electrical exam, such as the Journeyman Electrician exam. Depending on your location, you may need to obtain an electrician's license to work independently. An apprenticeship program could be a suitable option. It is always recommended to research different programs and consult with professionals in the field to determine the best path forward. Several types of electrical licenses exist, each permitting different scopes of work. A journeyman electrician typically works under the supervision of a master electrician and is qualified to perform most electrical tasks. A master electrician is a highly experienced electrician who has met specific requirements, including passing an exam and demonstrating years of experience. Master electricians can design, install, and oversee electrical projects. An independent electrical contractor owns and operates their own electrical business, often employing other electricians. They typically hold a master electrician license and carry insurance. A residential electrician specializes in electrical work for homes and apartments, while a commercial electrician works on electrical systems in businesses and other commercial buildings. An industrial electrician focuses on electrical systems in factories, manufacturing plants, and other industrial facilities. Each state or municipality has its own licensing requirements for electricians. These requirements typically include a combination of education, experience, and passing an exam. Some jurisdictions may also require continuing education to maintain a license. An electrical apprenticeship is a structured training program that combines on-the-job training with classroom instruction. It's a common pathway to becoming a licensed electrician. Apprenticeships are typically sponsored by unions, trade associations, or individual electrical contractors. During an apprenticeship, you'll work under the supervision of experienced electricians, learning how to install, maintain, and repair electrical systems. You'll also attend classroom sessions to learn about electrical theory, the National Electrical Code, and safety practices. Apprenticeships typically last for 4 to 5 years, and upon completion, you'll be eligible to take the Journeyman Electrician exam. The National Electrical Code, or NEC, is a widely adopted standard for safe electrical installations in the United States. It's published by the National Fire Protection Association, or NFPA, and updated every 3 years. The NEC provides detailed requirements for wiring methods, overcurrent protection, grounding, and other aspects of electrical systems. Electrical inspectors use the NEC to ensure that electrical installations meet minimum safety standards. Familiarity with the NEC is essential for all electricians. Electrical theory is the foundation of understanding how electrical circuits work. It covers topics such as voltage, current, resistance, power, and Ohm's law. Voltage is the electrical potential difference between 2 points in a circuit measured in volts. Current is the flow of electrical charge measured in amps. Resistance is the opposition to the flow of current measured in ohms. Power is the rate at which electrical energy is transferred, measured in watts. Ohm's law states that voltage equals current times resistance, volts equals amps asterisk ohms. Series circuits have components connected in a single path, so the current is the same through each component. The total resistance in a series circuit is the sum of the individual resistances. Parallel circuits have components connected in multiple paths, so the voltage is the same across each component. The total resistance in a parallel circuit is less than the smallest individual resistance. Three-phase power is a common method of electrical power distribution for commercial and industrial applications. It consists of three alternating current voltages that are 120 electrical degrees apart. Three-phase power is more efficient than single-phase power because it delivers more power for a given current. Common three-phase voltages are 208 volts, 240 volts, and 480 volts. Understanding electrical blueprints is essential for electricians. Blueprints provide detailed information about the electrical layout of a building, including the location of outlets, lighting fixtures, and electrical panels. Blueprints also show the wiring methods, conduit sizes, and other technical specifications. Electricians use blueprints to plan their work, install electrical systems correctly, and troubleshoot problems. Grounding is a critical safety measure in electrical systems. It provides a low impedance path for fault current to flow back to the source, which helps to trip circuit breakers or fuses and prevent electrical shock. The grounding system consists of a grounding electrode, such as a ground rod or metal water pipe, connected to the electrical panel. All metal enclosures and equipment are also grounded to provide a path for fault current. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current. When the current exceeds the rating of the device, it will trip or blow, interrupting the circuit and preventing damage to equipment or wiring. Circuit breakers are resettable, while fuses must be replaced after they blow. The size of the overcurrent protection device must be matched to the ampacity of the circuit wiring. Wiring methods refer to the types of cables and conduits used to install electrical wiring. Common wiring methods include non-metallic sheath cable, or NM cable, also known as Romex, electrical metallic tubing, or rigid metal conduit, or RMC, and flexible metal conduit, or FMC. The choice of wiring method depends on the application, the environment, and the requirements of the NECA. Conduit is a metal or plastic tubing used to protect electrical wiring. It provides physical protection from damage and helps to prevent electrical shock. Conduit is required in many commercial and industrial applications, as well as in areas where wiring is exposed to physical damage. The size of the conduit must be large enough to accommodate the number and size of the wires being installed. Electrical boxes are used to enclose electrical connections, such as outlets, switches, and splices. They provide a safe and convenient way to make connections and protect them from damage. Electrical boxes are available in a variety of sizes and shapes to accommodate different wiring configurations. The NECA specifies the minimum size and type of electrical box required for each application. Wiring devices include outlets, switches, and lighting fixtures. Outlets provide a point of connection for electrical appliances and equipment. Switches are used to control lighting and other electrical devices. Lighting fixtures provide illumination. Wiring devices must be properly installed and grounded to ensure safe operation. Electrical panels are the central distribution point for electrical power in a building. They contain circuit breakers or fuses that protect the individual circuits. The electrical panel receives power from the utility company and distributes it to the various circuits throughout the building. Electrical panels must be properly sized to accommodate the electrical load of the building. Electrical safety is paramount when working with electrical systems. Always de-energize circuits before working on them. Use insulated tools and wear appropriate personal protective equipment, such as rubber gloves and safety glasses. Never work on electrical systems in wet or damp conditions. If you are not qualified to perform electrical work, hire a licensed electrician. Electrical motors are used to power a wide variety of equipment, from small appliances to large industrial machinery. There are many different types of electrical motors, each designed for specific applications. Understanding the principles of motor operation and control is essential for electricians working in commercial and industrial settings. Transformers are used to step up or step down voltage levels in electrical systems. They consist of 2 or more coils of wire wound around a common core. When alternating current flows through one coil, it induces a voltage in the other coil. Transformers are used to match the voltage of the power source to the voltage requirements of the equipment being powered. Generators are used to produce electrical power. They convert mechanical energy into electrical energy. Generators are used in a variety of applications, including power plants, emergency backup systems, and portable power sources. Understanding the principles of generator operation and maintenance is important for electricians. Programmable logic controllers, or PLCs, are used to control automated systems in industrial settings. They are essentially small computers that can be programmed to perform a variety of tasks. PLC are used to control motors, valves, sensors, and other devices. Electricians working in industrial settings often need to be familiar with PLC programming and troubleshooting. Variable frequency drives, or VFDs, are used to control the speed of electrical motors. They allow the motor speed to be adjusted to match the load requirements, which can save energy and improve efficiency. VFD are commonly used in pumps, fans, and other applications where variable speed control is desired. Electricians working with motors often need to be familiar with VFD installation and programming. The ampacity of a conductor is the maximum amount of current it can carry safely without overheating. The ampacity of a conductor depends on its size, material, insulation type, and installation conditions. The NEC provides tables that list the ampacities of various conductors. It is important to select conductors with adequate ampacity to prevent overheating and potential fire hazards. Voltage drop is the decrease in voltage along a conductor due to the resistance of the conductor. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC provides guidelines for limiting voltage drop in electrical circuits. It is important to calculate voltage drop when designing electrical circuits to ensure that equipment receives adequate voltage. Short circuit current is the high current that flows during a short circuit fault. Short circuit currents can be very high, and they can cause significant damage to electrical equipment and wiring. It is important to protect electrical systems from short circuit currents by using overcurrent protection devices with adequate interrupting ratings. Ground fault current is the current that flows when a ground fault occurs. A ground fault is an unintentional connection between a hot conductor and ground. Ground fault currents can be dangerous as they can cause electrical shock. Ground fault circuit interrupters, or GFCIs, are used to protect people from ground fault currents. GFCIs are required in many locations, such as bathrooms, kitchens, and outdoor areas. Surge protection devices, or SPDs, are used to protect electrical equipment from voltage surges. Voltage surges can be caused by lightning strikes, power outages, or other events. SPD divert the surge current to ground, protecting the equipment from damage. SPD are commonly used to protect sensitive electronic equipment, such as computers and televisions. Harmonic distortion is a form of electrical pollution that can be caused by nonlinear loads such as electronic devices and variable frequency drives. Harmonic currents can cause overheating of electrical equipment and wiring, as well as interference with other electronic devices. It is important to mitigate harmonic distortion in electrical systems by using filters or other techniques. Power factor is a measure of how efficiently electrical power is being used. A low power factor indicates that a significant portion of the current is not being used to do useful work. Low power factor can cause increased energy costs and reduce system capacity. It is important to improve power factor by using power factor correction capacitors or other techniques. Electrical testing and troubleshooting are essential skills for electricians. Electricians use a variety of test equipment, such as multimeters, clamp-on ammeters, and insulation testers to diagnose and repair electrical problems. It is important to follow proper safety procedures when testing and troubleshooting electrical systems. Preventive maintenance is a proactive approach to maintaining electrical systems. It involves performing regular inspections, testing, and cleaning to prevent problems from occurring. Preventive maintenance can help to extend the life of electrical equipment and reduce downtime. Energy efficiency is the practice of using less energy to perform the same task. There are many ways to improve energy efficiency in electrical systems, such as using energy-efficient lighting, motors, and appliances. Energy efficiency can save money and reduce environmental impact. Renewable energy sources, such as solar and wind power, are becoming increasingly popular. Electricians are playing a growing role in the installation and maintenance of renewable energy systems. Understanding the principles of renewable energy is important for electricians. Smart home technology is becoming increasingly prevalent. Smart home devices can be controlled remotely using smartphones or other devices. Electricians are often involved in the installation and configuration of smart home systems. Electric vehicle charging stations are becoming more common as electric vehicles become more popular. Electricians are needed to install and maintain electric vehicle charging stations. The NECA Article 220 provides requirements for calculating branch circuit, feeder, and service loads. These calculations ensure that the electrical system has sufficient capacity to handle the expected load. Article 230 covers service entrances, including the service conductors, overcurrent protection, and grounding. Article 250 provides comprehensive requirements for grounding and bonding electrical systems. Article 300 covers general wiring methods, including requirements for conductor insulation support and protection. Article 310 provides tables for conductor ampacities. The tables are based on the conductor size, insulation type, and ambient temperature. Article 400 covers flexible cords and cables. Article 430 covers motors, motor circuits, and motor controllers. Article 440 covers air conditioning and refrigeration equipment. Article 500 covers hazardous locations, such as areas where flammable gases or dusts are present. Article 517 covers healthcare facilities. Article 547 covers agricultural buildings. Article 600 covers electric signs and outline lighting. Article 625 covers electric vehicle charging systems. Article 690 covers solar photovoltaic systems. Article 700 covers emergency systems. Article 701 covers legally required standby systems. Article 702 covers optional standby systems. Understanding these articles is crucial for safe and compliant electrical installations.